you have room at the top of page 531. We're going to learn the shortcut for graphing these faster than having to do all the transformations we did in our first chapter. And we're going to call it DAB C. That's going to be our name for this shortcut for graphing. Ooh, what grade were you guys in with like the DAB thing?
Middle school, grade 7.
Middle, so it was like traumatic for you.
Oh. Hit the DAB, so.
See, still makes people laugh. I'm only going to be able to enjoy that for a couple more years. And then kids will be like, what's that?
I got 3 more years left.
I got at least 3 more years?
Jar, can you eat that?
It's so funny, because really, it's like the stupidest thing, but for whatever reason, it was so embarrassing to do, right? It makes people giggle like crazy when they see it. Just terribly funny. All right. It is like, why is it really funny? But it causes everybody to laugh. Every time. Okay. So, when we did transformations, we always did our stretches and compressions first, and then our transformations afterwards. And that is the proper way to do it all the time. However, with sine and cosine, you can do it as a shortcut by actually starting with your d value. So when I get you to graph this, the very first thing you're going to do is draw your center line with the dotted red line, draw your sinusoidal axis. So this method, if you haven't figured it out, the DAB-C method is actually the order that you do it. You do the d value first. After the d value, you've drawn your center line. You then use your amplitude to label your maximum and minimum values. Because your amplitude is the distance from your center line to the maximum and the distance from your center line to the minimum. So you've got your center line already drawn. You can use your a value to find your maximum and your minimum. Ready? B value. Whew. More words than we've written all semester, I know. Use your b value to calculate the period. And there's the formula. Period is 2 pi divided by your b value. Label your period on the x-axis, and we always divide it into 4 equal sections. Just like you had the 4 axes family sections on your regular sine and cosine graph, now you have 4 sections on your new graph. What letter are you on the, huh? Or like really far?
Oh no, just a little bit.
I know it's smaller. Divide it into 4 equal sections. Tell me when you're done the top part, I'll make it bigger for everyone again there.
After, can you just like do this again, but like so that we can see the rest of it?
Oh, p-value to calculate the period, label your period on the x-axis, and divide it into 4 equal sections. Then, the dash. Because it's dab, dash, C. The dash means something. You have to graph without the phase shift in a dotted line. So you thought the dash was just there so it sounded better, dab C, and you wouldn't get confused with debit? No, it actually means something. You need to graph without the phase shift with a dotted line. Then finally, the C value. Translate your graph left or right. Okay, crazy story. I was reminded of crazy name story. How would you say the following name? Okay, how do you pronounce that name? Yes, Ladasha. Nailed it. Can you, like, as a kid, can you be like, come on, Mom and Dad? Every time at roll call, what do you think they'd say? Like, Leah? S-S-S-S-T?
Yeah.
Forrester? Forrest?
Forest.
Forrest. That's pretty bad too. Yeah. But Ladasha, you have to say that all the time to your teachers, right? I mean, think they like she had a brother, like Slasher. And this would be terrible because every once in a while people get confused and call you Lahaifana. All right. Is that funnier than I thought it was? It is. Okay, there we go. So. All right, so here's our first example of how, and usually with sine and cos graphs, you get them like this. Graph y equals 3 cos 2 x minus pi over 4 plus 1. So we're going to go through how to use the dab-dash-c technique. How to use the dab-c technique to make this really easy. Starting with D. The D is your sinusoidal axis. It is a plus 1. So you go plus 1, up 1, red dotted line at y equals 1. That's your sinusoidal axis. Put a check mark over the D. That's step 1. Simple as that. All we need to do is draw our sinusoidal axis. Next, we use our amplitude. Our amplitude is 3, which means the distance from our center line up 3. If I go up 3, 1, 2, 3, up to 4, that will be my maximum. And if I go down 3, 1, 2, 3, minus 2 will be my minimum. That's the only thing you have to do with the A. The A value says use your amplitude to label your max value and your min value on your y-axis. Next, the B value. The B value finds your period. I've done that up here. So you can maybe write period is equal to 2 pi divided by your b value. Happens to be pi. Choose a random spot on your graph and mark it as pi and divide it into 4 equal sections. Label those sections. Half of pi, pi over 2. Half of pi over 2, pi over 4. And then 1, 2, 3 pi over 4 will be that. That's all you need to do for your b value. The dash. So this is a coast graph. Where does a coast graph normally start? A coast graph normally starts at a maximum. Draw a point at your maximum, and then go maximum, center line, minimum, center line, maximum. And draw this with a dashed line, or a dotted line. Because this is your graph without the shift. That's what the dash says. Then finally, you need to do your shift. In this case, we're shifting pi over 4 to the right. So I will take my first maximum point and shift it pi over 4 to the right. My next point, shift it pi over 4 to the right. Pi over 4 to the right, pi over 4 to the right, pi over 4 to the right. And I can now draw my graph through those points. And this is all we need to do to graph these with 4 complicated transformations to graph it completely. Okay? We're going to do another example. Everybody done this one? Yes, good. Almost? Not even almost. Oh my goodness. Good? All right, one more. Again, off to the side, I'm going to write tab C. Now, sometimes you can already see ahead of time what's going to happen. Can you see that my amplitude is 4 and my sinusoidal axis is at -2? So as far as where I'm going to put my x-axis, put a little bit higher up because I know that at -2, that's going to be my center line. My amplitude, even though there's a -4, the amplitude is still +4. It means you're going to go up 4, 1, 2, 3, 4, up to 2, down 4, 1, 2, 3, 4, down to -6. Your A value is done. Your B value finds your period. In this case, your period is going to equal 2 pi over 3. So I find somewhere on here and mark 2 pi over 3 and divide it perfectly into 4 equal sections. Half of 2 pi over 3, pi over 3. Half of pi over 3, pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. Which you could reduce to pi over 2, or you could leave it as 3 pi over 6. Your B value is done. Now we have to do the dash. The dash says, draw the normal sine graph. This is a negative sine graph. Normally, where does a sine graph start? On the center line going up, but because there's a vertical reflection, it's going to start on the center line going down. So we go middle to minimum, back to middle, to maximum, back to middle. And we've now done the dash. Finally, we need to do the shift. It's pi over 6 to the left. So on my graph, I'm like, okay, this is pi over 6, this distance, so I have to make it that way. Pi over 6 to the left. This point will go here. This point will go here. This one shifts over that amount. This one shifts over that amount. Put arrowheads on, show that it continues forever. And there's our graph.